the linear equations in mathematics. I told you earlier something about the linear equations, but now I have something more about linear equations. What do you mean by linear? Linear is the adjective form of line. So, linear means something relating to the lines, because the pairs of linear equations invariably represent a pair of straight lines of one degree. It's very important to remember that the coefficients of the variables of the linear equations determine the directions of the straight lines. When the linear coefficients of the linear equations are improportional, are not proportional to each other, they represent two straight lines not of equal directions. So, the inequality of the coefficients of the variables of the linear equation invariably imply the unequal directions of the straight lines constant. For example, you see, I am citing some numerical examples. You see, Hori consumes 3 berries and Madhu consumes 5 berries. What's the total number of berries they consume? It's evidently 8. Only 8, nothing more or nothing less. Because here you see the proportion of the coefficients of the constant equations are not proportional to each other. They imply the unequal coefficients, and the inequality of the coefficients of the linear equations invariably direct the unequal directions of the straight lines. Either they are oblique or they intersect each other at a point. Because the coefficients here of the variables of the linear equations are not proportional to each other. So, I cite you the example. Hori consumes 3 berries and Madhu consumes 5. What's the total number of berries they consume? And the answer must be 8. Because it's nothing less than or more than 8. It's exactly 8. Because the straight lines intersect at a point to give unique distinct solution. And on the contrary, the equality of the proportions of the coefficients evidently imply the equal directions of the straight lines constant. The equality of the proportions of the coefficients of the variables of linear equations invariably imply the equal directions of the straight lines constant. And I cite you some numerical examples. You see, Hori consumes 1 berry, and Madhu consumes 2 more than him. Here, the answer mustn't be some distinct or unique. It must be many, because we calculate the number of berries Madhu consumes on the basis of Hori's. If Hori consumes 1 berry, Madhu must consume 2 more, 3 berries. If Hori consumes 2, Madhu consumes 4. If Hori consumes 3, Madhu consumes 5. So, we calculate the number of berries Madhu consumes on the basis of Hori's. So here, the lines must be coincidental. They must be coincidental because you calculate the number of berries Madhu consume on the basis of Hori's. So, 1 to 1 corresponds here. 1 point corresponds to other point of another straight line. If Hori consumes 1 berries, Madhu consumes 3. If Hori consumes 2, Madhu consumes 4, etc. So the lines are coincident. The lines overlap each other, agreeing in innumerable points. So here the answer, the solution must be innumerable. And then you see that the directions of the straight lines are equal. On the first occasion, the directions of the straight lines are not equal because the proportions of the coefficients of the variables are not equal. They imply the unequal directions of the straight lines. They intersect each other at a distinct point. But here you see the straight lines intersect each other in innumerable points because we calculate the number of berries Madhu consumes on the basis of Hori's. So, and these straight lines intersect each other in innumerable points so that they must be coincidental. And the straight lines are for equal directions. One overlaps other. And then the next, the 3 incidents of the linear equations on intersecting each other at a particular point, at a specified point. Next, overlapping each other in many innumerable points or coinciding each other with innumerable points. Next, you see the lines are parallel. What happens? I am citing you another numerical example for your better understanding. You see, if Hori consumes some berries and then Madhu also consumes some berries, and I will ask you, what's the total number of berries both of them consume? You cannot evidently answer it because there is no answer. Hori consumes some berries, unknown, and Madhu consumes some berries, unknown. You cannot have a solution with the 2 unknown data. So the lines are parallel to each other. Another thing you see, here you see on the first occasion, when the straight lines intersect each other, the coefficients of the variables of the linear equations are not equal to each other. They are unequal. And you say that A1 by B1 is not equal to A2 by B2. So they imply 2 intersecting 2 oblique straight lines. In the second case, A1 by B1 is equal to A2 by B2 is equal to C1 by C2. Third occasion, when the straight lines are parallel to each other, what happens? The coefficients of the variables must be proportional to each other because the lines are of equal directions. When the lines are parallel, they must be of equal directions. Unlike the first occasion, when the lines are intersecting each other at a specified point. And in this second occasion, the lines also have same directions because the coefficients are equal, they are proportional. The coefficients of the variables are proportional. So, the straight lines involved must be of equal directions. You see, the straight lines are of equal directions. One straight line overlaps the other. One straight line intersects the other at the innumerable points, giving innumerable solutions. I have cited you the numerical example. If Hori consumes 1 berry and Madhu consumes 2 more than him, Madhu consumes 3. If Hori consumes 2 berries, Madhu consumes 4. If Hori consumes 3 berries, Madhu consumes 5. So on and so on. Here we compute, we calculate the numbers of berry Madhu consumes on the basis of Hori's. So the 2 straight lines, couple of straight lines representing the linear equations intersect each other at innumerable points to give innumerable solutions. You will see the solutions are innumerable in number. Unlike that on the first occasion, which is only one. It was 8, but it has many. 1, 3, 3 plus 1, 4, 2, 4, 4 plus 2, 6. In this way, the solutions are innumerable. In the third case, when the lines are parallel, you see, whenever the lines are of equal directions, and you see the coefficients of the variables are the balance of a vehicle. The balance of a vehicle, they determine the directions of the straight lines. Where to they go? Where they go to? Here you see A1 upon A2 is equal to B1 upon B2. These are the coefficients of the variables of the equations. They are equal. So the straight lines must be of equal directions. The equality of the coefficients of the variables invariably imply the equality of directions of the straight lines constant. Equal directions of the straight lines constant. Here that happens. But you see here the proportions of the coefficient of variables bear an equal proportion with the ratio of the constants. So they intersect each other in innumerable points. Intersect whenever the coefficients of the variables along with the ratio of the constants are proportional. Then they must intersect each other at innumerable points, giving innumerable solutions. Here, the coefficients, the proportion of the coefficients bear an equal proportion with the ratio of the constants. So they intersect each other in innumerable points. But here, when the lines are parallel, they do not intersect at any point, they do not agree. They are arbitrary. They want to proceed in parallel directions without an agreement. So, you see, the ratio of the constants is very important. They play a vital role in solving the equations, in giving the solutions. Here, as the ratio of the constants are not proportional with the coefficients, so the lines are parallel without giving any solution. But they have equal directions. I have told you earlier, the coefficients of the variables of the linear equations, the equality of the coefficients of the linear equations imply the equality of the directions of the lines constant. On the contrary, the equation, the proportion of the coefficients when do not bear an equal proportion with the ratio of the constants, they are parallel. They do not agree with each other. They are arbitrary without giving any solution. They want to proceed on their own directions without caring for the other. That's what happens here. You see, it's a vehicle, linear equations, and this equation also is applied while fixing a balance to a vehicle. A balance to the vehicle, you see, in this direction, in this direction, in this direction. Then you understood everything, and the role of the ratio of the ratio of the constants are very important. For agreeing two lines, for making two lines agree, as far as the linear equations are concerned, the role of the constants. Here, the ratio of the constants is not proportional with that of the coefficients. But here, the ratio of the constants is equal to the proportion of the coefficients, though they meet in innumerable points. Here, they do not agree. And here, yes, the coefficients of the variables are not equal to each other. They agree, but at only one point. At only one point, because they do not agree. They won't imply the equal directions. If two straight lines do not imply equal directions, they must intersect. They are oblique, not coincident, neither coincident nor parallel. They are oblique. So they must meet at a point to give a solution. And here I have cited the numerical example. If Hori consumes some berries and Madhu consumes some berries, you cannot at all find the answer, the solution, because two unknown data are here. Which is what happens here in the case of the parallel straight lines. Do you understand? I told it for your better understanding. And the particular sum said 7x minus 15y is equal to 2. X plus 2y is equal to 3. We have to find the solution of this pair linear equations. We call it simultaneous equations because the pair equations are solved at a time to find solutions. So you must test the two equations. In what form they are? We can rewrite it. 7x minus 15y minus 2 is equal to 0. X plus 2y minus 3 is equal to 0. Here, you see, A1 is equal to 7. A2 is equal to 1. B1 is equal to minus 15. And B2 is equal to 2. So, A1 upon A2 is not equal to B1 upon B2. A1 upon A2, 7 by 1, is not equal to minus 15 by 2. So, evidently, the pair linear equations representing straight lines must intersect at a point, at a single point, to give a specified or unique solution. And we proceed in this manner. The solution of the linear equations come under two categories. One is substitution method and the other is elimination method. You know, substitution method implies you have to substitute. You will find the value of one variable in terms of other and substitute it in the second equation in order to get the value of one variable. When you get the value of one variable, you will substitute it in the other to get the value of another variable. So, here, in substitution method, what we do? You see, 7x minus 15y is equal to 2. And x plus 2y is equal to 3. We can find the value of x here from the second equation in terms of y. From the equation x plus 2y is equal to 3, we get x is equal to minus, x is equal to 3 minus 2y. And we substitute it in the equation number 1. So that is what? 7 into 3 minus 2y minus 15y is equal to 2. Implies 21 minus 14y minus 15y is equal to 2. Implies minus 29y is equal to minus 19. Implies y is equal to 19 upon 21. And we know that x is equal to 3 minus 2y. Implies x is equal to 3 minus into 2. Implies x is equal to minus implies x is equal to 87 minus 38 by 29 is equal to is equal to 1 over solved.